Well, I thought this was an Amstrad 900, not a 901. Now, I've been told this is a genuine one. So, one of the things you can tell straight away is that the instruction book covers the 900 and 901. So if the instruction book doesn't cover the 900, it's going to be the Hong Kong one. And then, of course, it could be the fake one or the real one. We've also got the guarantee. It's taped in there, and we've got a sticker. So, is this the Action Man mic or the later one? We've got the impossible to get power lead. Got the later mic. Belongs to an end user with a massive collection of sets. So we're treating this trade. I'll put the instructions and that bag and those accessories back in the box. And we'll make sure there's no stuff on there. I'm going to take both the lids off and then put it out of harm's way. The lid, that is. So hopefully there shouldn't be any silliness. Now normally you've got these daft little 2.5 watt resistors to make up the drop or the ballast resistor for the PA, and then you end up with the set only doing 2.5 watts. So we will be changing that, but whatever comes out I'll put back in the box. So it's like new, isn't it, that? Get the light on it. So I know we've got an Amstrad, sorry, this is the Amstrad. I know we've got a Cobra, no we haven't, same thing. We've got from the trade a chassis to do, which is Colt 295A, and we've got retail. He actually drove 200 miles with it, and that's a Fidelity 1000. He's going to drive 200 miles back. Don't care how naff you think that is, it's very important to him sentimentally. Right, to be honest, it still smells of new radio, that. So it's had work round here, round here. So it's not new, it's been used. So why would it have work round there? That's the detector. Right, well then, don't normally have good squelch, do they? No, Mr. Tango, they don't. Well, I think our cassette upload has been, looks like it's going to be pretty popular, of that very frightfully British method of using your open channel wireless. So we won't use that mic, I'll put that on one side for now. We'll use our standard replacement mic, but we'll test that at the end and just check the deviation is correct for it. So use a standard Cybernet wiring mic, use Cybernet 002F chassis. I'm going to switch it on carefully because I don't know when it was last powered up. connectors weren't even available as a spare part from the word go. We do the square and round type, the later one, and we've even got the chassis end as well for those. The thing that kills all these little sockets and things is the price of postage has shot up. Second class large has gone, well, I think it was about 95 pence 18 months ago, then it's 115, now it's 145. They don't mess about with 5% increases. They take it from 115 to 145, just like that. And a lot of these things, they get to the stage where some of the couriers are going to be the same price, and you're going to have tracking information built into the base price. So the post office is shooting themselves in the foot. They really are. I had a favourite post office in Grantham, which was Hill Avenue. Pull onto the forecourt in front of the corner shop and go and take things in like parcels. Now the post office is not that's gone, it's back to residential, and the main post office in town isn't in the drab building that it has been since the 70s, some concrete dreadful drab building which was a pain to get to anyway. No, it's now at the back of W.H. Smith's, so it's got real basic opening hours, and you can't be walking in there with piles of parcels. So shooting themselves in the foot once again. Little chef restaurants did just that. The ones that weren't making a huge profit, they deleted, and then it gets to the stage where you think, well, I can't rely on there being a little chef, so I won't bother going at all. And that's, sometimes you think, if you've got, supposing you've got 100, supposing you've got 200 restaurants, as long as they're not actually losing money, it's all part of the thing. But because at least they're generating employment and all that kind of thing. So I'd be very happy if I had 200 restaurants and we only had 5% of them actually making a profit, as long as the other ones weren't actually losing money. But no, they cream off the 5% and think, well, these are making. Then you can't buy in the same quantities, and then of course the whole thing turns. But there you are. I'm obviously too old. Right, transmit, picture-in-picture on, radio at 9 volts on, powers it up, and we have nothing. We have a short circuit. Okay, so let's not use the power lead. Look into that later. We'll go straight into the connector like we usually do anyway. We don't have a short circuit and we're lit up, so something, look into that. Right. So we're lit up, 130 milliamps, we'll go to 13.8 volts. Now 213 milliamps, channel 20. Transmit is 3 watts. On the 3 watt scale, we've got full scale deflection. Pop it down to channel 1 and 3.1 watt. Channel 40 is probably 2.9. No, 3. Back to channel 20, and it's 210 milliwatts. That's not adjustable, but hopefully as we take the power up, we'll get greater on there because it should be 400 milliwatts. It's not adjustable, so it's what you get. It's what you get. Pop that back on. That valve resistor is the right one, but even that massive one's only about 3 watt rated. Transmit current is 1.3 amps, so it's a lot of current for 3 watts output. Deviation, take this with a pinch of salt because the test set has a stag on its deviation meter sometimes. While it's 1.5, I'll put on that. And what we want to do is to get rid of the rudder bleed. We'll check it in PA mode. Whichever socket that is. Plugged it in the right one. Testing 1 2, testing 1 2. So that works. Plug the test equipment now into the extension speaker socket. I always tread carefully with that because the last thing I want to do is, if you've got a short circuit into the radio, I don't want to put a short circuit into the test equipment, do I? Right, so on transmit, what does the meter read? It doesn't read anything because the power connector's dropped off, which is why we use the power lead. Yeah, right. Reads all 5, which is ridiculous. The frequency, I'm going to take this slightly with a pinch of salt, because when I had the test gear on, when I had the test gear on 15 minutes, but yeah, it does need to come up, and it may not come up. 79075. I really like them to be above 086. If it's really less than 100, I'd really be wanting to change the reference crystal, but we'll see what happens. I've had one of our viewers send me a couple of reference crystals, which is very good of him. Let's see if we can just bring that up right now. We'll adjust it again later. It saves me faffing with the signal generator. That's fine. It's 119. That's what we can get it to. That's near enough from 125. Receive. I will put the same into the signal generator. 79. I'll put it in as wherever we were, 118 was it? Just slightly low, so I don't get anything lopsided. Put the cyanide meter on. Let's go and see what that says. Oh, there we are. Tell you what, that's really good. Let's check our RF gains in full position. So it's 0.24 microvolts. For 10 dB, 0.21 microvolts. For 20 dB, if it does it, it does. 0.92. Squelch is usually lousy on these. Full squelch. Is He's 24 microvolts. I like it to be 100, but you know, there you go. At the sensitive end, set the squelch threshold on the radio, and switch the signal generator back on. It's 0.4. So we'll go to 100 microvolts. Let's see what the S meter reads. It reads S9, which is correct. So at the moment that wouldn't need adjusting. Doesn't have a meter lamp. I've now checked all the switches because we checked the Roger Bleak was on. We've checked all the potentiometers. We've checked all the sockets. So that's gone down the tick-off list very nicely, thank you. We'll start by doing the VCO. Never remember whether these are floating chassis or not. Got a memory like a sieve, always have had. So I'll tell you what, we'll put it to a can anyway. So it's the far side of capacitor. Is it capacitor 9 that? I'm going to zoom in. I've had a request to zoom in on resistor 4 on the Cybernet 134 chassis, which I will do next time we have a Cybernet 134 in. But just to be absolutely clear on this one, 002 chassis, we'll just zoom in on this one. So this green capacitor here is capacitor 9. So I've got the control panel facing me. So the lead, the far side, is the VCO test point. I've done the VCO 100 times on videos on this channel. I'll just go back to normal camera position. So we actually get so you can actually see the meter. I'm on channel 1 on these. There we go. It should be somewhere around 2 volts. And it's somewhere around 2. I'm going to take picture in picture off just for a moment because it's blocking the meter. So we've got 2.2 volts there. It's going to transmit. It should be somewhere around 1.8 volts, and it's 1.6. That's absolutely fine. And on channel 40, it needs to be somewhere around between 3 and 4 volts. And it's 3.6. I think it's 2.5 on transmit. You know, I don't need to mess with it because one of the things about the manual is it doesn't tell you what meter it's intending you to use. So normally it will say using if they're expecting to use I'm not going to say digital meter because these sets are just before digital meters. They're wanting to use a really sensitive meter such as a digital meter. They'll say use a VTVM for vacuum tube voltmeter. Of course they became FET voltmeters, didn't they, when we went solid state. So it would say use a high impedance meter. Now the industry standard meter in the UK is the AVO 8, which is 20,000 ohms per volt. So most service manuals will be with reference to that, and of course that draws current, so your voltages are different. So we don't really have a real reference, but experience of doing this for 40 years tells us where that should be, and it should be about there. So it should be somewhere between 1.8, 2 point something volts on the low end, and it should be somewhere between 3 and 4ish at the high end. But this set is definitely in lock. So we're going to do OK, we're going to do OK. I'm very happy with that. I don't want to necessarily disturb the trimmer. They're easy to get dirt in, especially when it's 40 years old. We then end up with the set going back and it playing up. So you kind of rob for your own back if it doesn't need adjusting. We could change them willy-nilly, but it increases the cost to the customer. So there you go. Let's see if we can do a tune-up. That's not being messed with. I think that's the top and bottom of what I'm trying to tell you. Right, see if we can get, I'll go to channel 20, so we're in the centre of the band, and we'll put picture in picture back on, well I've remembered, and let's see if we can get a little bit more than 3 watts. If I can't get 3.6 out of this, we'll be changing the ballast resistor. We'll take that clip off. So I want to make sure these are in the centre position. I already need to be in the 30 watt scale. So 3 watts. Three watts. 3.1 watt, that was slightly out. .1. I don't like to see those coils stretched. It is a tuning method. Mac's unlikely to actually mess with these, but we need to mess with them with the spectrum analyzer. Just make sure that if closing it up is going to change that. They've got that kink there in the right place. Yeah, that's okay. So now we'll tune this one. With 3.5. Go back to that one. The kink in that one. Why have we got a kink in that one? That's actually causing it to lose power. No, 3.5, I says 3.6. We're going to change the ballast resistor. Okay, so that's changed that. They're the same physical size, that's the one that's come out. They're identical, but these are 7 watts and these are 6.5 watts, that, and these are 3 watts. So I can't expect to get 4 watts like when there's a 3 watt resistor in there. So the 3 ohms, 3.3. We've discussed a million times before that there's some daft people link those out. The radio then delivers about 7 watts, but it doesn't deliver it on 27 megs. It delivers about 2.5 watts on 27 megs, and the rest of it on 112 megs aircraft band. So they get the cheap power meter, and oh look, it's doing 7 watts, and it isn't. It's doing 2.5. I showed you the demonstration that before. So we're using a selective power meter on this test instrument, so it more or less shows what's on this band, and the band it's on is it's it's pretty wide. It's 10 to 20. Sorry, it's 24 to 33 megs, but it's not going to show harmonics. Right. So we want to show the main meter, which is there. Why isn't it coming up? Because I can't press the buttons. Right, so we're set back on channel 20. We'll have to reconnect it to power. Supposed to be doing Take 2000 programming demonstration. I'll sort this power lead out. But that means going outside to one of the sheds. I'm going to put. Someone's kindly sent me the software to program the Take 2000, which is more than 4 channels, because normally we only see the 4-channel ones. The way business radio works in the UK is the government give you one frequency, one channel for every 100 mobiles. So if you've got a taxi outfit with 120 cars, you'll be issued 2 channels. So the chances of ever seeing sets with 4 channels is, may as well make the radios easy and have sets with no adjustable channel. But most of the Take 2000s are 4-channel, but some of them are greater than that. And you can imagine there is an appeal to radio hams for ones which do more than 4 channels, although most of my radio ham kit is single channel, because I really don't need to bother changing channels. And when I do, I only need one other channel. So it's like S20 for a copy, come on. Yeah, got you. Knock it up to SU22. And if it's busy, well, I'll catch you another time. Bye. You can see how enthusiastic a radio ham I am. I've been radio hamming it since 1979, and I'm just as enthusiastic. I'm interested in sorting radios out, not talking on them. Right. Power on. And now we're at 3.5 watts. Hope we get a bit more than that, having done all that work. No, 3.6. I've hit the 3.6. Oh well, it's going to be one of those, isn't it? Just check this previous one. A bit more when it's cooled down. Just check that gap there. Yeah, that's exactly where it needs to be. Okay, so it does 3.6 watts. Well, that was an expensive job to add 0.1 watts to it. Right, let's see what it does on channel 1. Does 3.5 watts, and on channel 40 does 3.5 watts, and on low power. So if you add 0.4 to what I'm telling you, which will then read like any normal RF meter, we're already at, if you add 0.4 to 3.6, you're at 4 watts, aren't you? So take what I tell you with a pinch of salt. So we're now, this has come up, we're now at 270 milliwatts. So after a retune, what have we gained? We're now at 1.38 for a tiny increase. Deviation, I'm going to use the test set behind, and say I can't trust this one on deviation, done on everything else. So we've got 3 of these Marconi test sets, and this is the one on this bench, and we only do the CB videos on this bench, so not moving them around. It's no inconvenience to turn round and plug into the quartz lock 282A on the bench behind. Wallow. Yeah, it's just exactly the same, it's low. Well, it's nice to see a radio that's not being fiddled with for once. Wallow. There we are, 2.5 peaking. We'll turn that off and save some electricity. My 3.1 kilowatt solar panel scheme today, it's really dull and raining, has so far generated 100 watts. It's that dull. So my electricity bill today will be more than it normally is. I'll need to do these service jobs the rest of the week in candlelight, won't I? So let's see what the deviation is on this meter. Wow, it's exactly right. It's 2.21 to 2.2 to 2.5. So this meter's reading correct today. What we usually do is set it on this one and then just verify it with the other. 9 times out of 10, this is right, but it's got a capacitor issue. And I say to take this off the bench would mean a couple of weeks where we just wouldn't do any service work on CBs. So that will be it. So that's the transmitter done. We're going to have to look at this RF meter there, aren't we? Because it's going to go banging across. It should be lighting 4, not 5, especially considering it's doing 3.6 watts. We'll give that a twiddle. There we go. So it's definitely 4. And on low power, it normally should light 1. It does. There we are. Receive, well, I'm to be surprised if we can get an improvement on that because it's working so well. So we'll put the oscilloscope on, we'll go over to the oscilloscope just like that, and we'll put enough signal, 100 microvolt input for a decent sized trace, and then we'll set the detector. Tiny adjustment there, but nothing significant. Turn that off and we'll go over to the cyanide meter, and we need to drop that to about 4 dBs like that, so we're not saturating the receiver. And then we'll go through the front end and the IF. No improvement. Fractional improvement. Fractional improvement. Go through these IFs. The biggest signal on and check those again. You know what, that's really well optimised at the factory, because normally they're just tuned to a line and the conveyor belt moves on. You know, it's going to be wop. There's your there's your line. It's hit the minimum and off it goes. But that has been really carefully aligned at some point in its life. So although we've got some little ones out on the transmit, and that brought us 0.1 as an improvement, and another 0.1 with the resistor. Well, we brought it up from 3 watts to 3.6, didn't we? But that was in tuning of those two. So this is absolutely fantastic. So let's just look where we now are. So go back to the normal range, because I was on a lower range. I would say that's on the 12. And we're now doing 0. Well, I say it's 0.25, which actually makes it worse. But when we've changed the detector, and that can affect that. And I'll show you something else as well in a moment, because if we change the tone control, that would also affect it. But I kept it at centre point. So there's our ten, and it's 0.21, which is exactly what it was before. And then our 20, 0.9. So basically it's the same, isn't it? We've just twiddled it around and made sure it's right. So 100 microvolts on the signal generator. Let's put that over to the attenuator. So you can see we've got 100 there and 0 there. And we want this to read S9, which is now not correct. There we go. We turn the signal generator up to 300 microvolts, 1 millivolt. I actually want that to read plus 30 at this point. This is where you have to do some jiggery pokery. And now drop it to 9. So there we go. We've still got S9 on 9 on 100 microvolts, and we've got the plus 30 coming in, which is what we want. Can usually achieve that. Now whether or not we can improve the squelch is another matter. So put the squelch to full and see whether we can gain anything. So I want it to open at 100 microvolts. It is doing, yeah, yes it is. And on the sensitivity point, set threshold on the radio, signal generator back on. It's 0.33. So we've actually got better at both ends somehow. That's probably because I've redone the receiver despite it not looking like it's made any difference. So it's 0.33 microvolts, and it's now 100 microvolts, which is where we want it to be. So we want the S meter to now read 100, and because of the retune it now reads plus 30, so it does need adjusting. So that once again, yeah, that's correct again. We're done. Now we'll just go back to one final thing. We'll go back to the frequency counter and see where we are with that. 27791119, that'll do. So it didn't alter. So we'll just check the customer's factory mic. I'm going to have to take it out of its bag. One two one two Wallow. 1212 Wallow. 1 2. That's not working. The chances are we're not supposed to do mic repairs here. chances are it's just got tarnished contacts, because it's actually struggling to receive as well, and the receive of course goes through the microphone, as you well know. The reason being, you can use a telephone handset made specially for the purpose, like they have in police cars in the UK. Why do they have telephone handsets on the two-way radio in police cars? They can then switch to handset only instead of it coming through the loudspeaker in the car, and then the prisoner in the back of the car can't hear what the police controller is saying about him or her. I'm going to switch the set off. We'll just put some service or switch cleaner in there. We'll see if we can put it in both ends, because it's open-ended, and just work that around a bit and hope that that's fixed it. And this will be typical of a microphone that's not been used for 40 years. You're going to have tarnishing on the silver plated contacts. So if you actually pressed the PTT bar about 50 times, it would self-clean anyway. I'll put the radio back on. Wallow, 1 2 1 2 1 2 1 2 1 2, wallow. 1 2 1 2 wallow. 1 2 1 2 wallow. Now we can listen to this on public address. Testing 1 2, testing 1 2, testing 1 2, 1 2 1 2, testing 1 2, testing 1 2, testing 1 2. Testing 1 2. You've got to fully press this one home. Testing 1 2. Like I say to everybody with original mics, use a standard replacement mic and keep the original mic in the box. What you don't want to do is to wear it out. Mics are always the weakest link in the chain. We'll put it back in its Johnny. Want to show you the tone control. So we're going back to the cyanide meter, and we'll get 100 microvolts on the radio. So we won't at all. We're going to get 12 dB cyanide, yep. Now I'm going to turn the tone control down so it's bassier, and you'll see the cyanide improve. So now if I read that off, remember it was 0.25 microvolts. It's now 0.22 microvolts with the tone at low. And now if I turn the tone to high, we'll introduce more noise, but it will sound better to me. And we've got the 0.25 microvolts there. There you are. So that's where we're keeping it. Right. Put the lid back on. It's still pouring with rain. We have a stream runs through the garden here, which is one of the sources to the River Slee, and there's only about 6 days a year there's ever any water flowing, and today is one of those days. It started about 4 o'clock yesterday, so we've got the River Tango. I won't clean somebody else's work, So that's worked out a very nice set. It's really good receive, and the 3.6 watts on transmit is 4 watts of anybody else's watts, so we're there. And the number of times we've seen those power connectors is really few and far between. Of course, I don't know what he paid for it. He probably paid 100 quid for it. So these were £90 new. They're £89.99. The 900, the other model without the PA facility and without the Roger Bleed, was £79.99. Then you started getting the cheaper version. The Hong Kong one was I think it was £59.99. Then you got the fake Hong Kong version, which was £29.99. So you get what you pay for, don't you? This is a really good set. Okay. So, let's see whether we can hear anything if we plug in our Antron 99 roof aerial. One Niner Roger. A Roger. Yeah, you're joking. Right. That's it. Switch everything off. Thanks for watching. Genuine Amstrad 901 from 1981.